The fourth Hess's law problem gives us an example where we have to watch out for the state of the chemicals. So our target reaction, H2SO4, that's sulfuric acid, turning into sulfur trioxide gas and water gas. We don't know that enthalpy, but it's our target. We're going to find the enthalpy of that reaction. We're given these three reactions, number 1, number 2, and number 3, and their measured enthalpies. So first thing we need to do is go through and check, are things lined up correctly for the sides of the arrow? And right away we see in equation number 1, it is not lined up. It has the sulfuric acid on the wrong side. So we're going to have to flip this equation. And when we flip it, we also have to change the sign of its enthalpy. So we flip it to get it on the sulfuric acid on the left side of the arrow. Our second one, we see that we need sulfur trioxide gas, and it is on the proper side of the arrow, so that one's fine. And we need water in the gas phase on the right side of the arrow, so our last equation has water in the gas phase. This is one of those things where don't be fooled because this one has water, it's liquid. This one has to disappear, and it does. This one has to disappear, and that water is going to make it disappear. So because we flipped number 1 over, I'm going to cross that one out. We're not using it at all anymore. Now we have H2S. That is not in our target equation. It is going to cancel because it's also right over here. So I can cancel the H2S out. I already saw how I could cancel this liquid water out. And these two oxygens, they're going to cancel out because they're one on each side. So now I'm left with, on the left side of the arrow, only sulfuric acid, and on the right side of the arrow, only sulfur trioxide and H2O in the gas phase. So I can now add these together and add together their enthalpies, and I end up with my target equation. The enthalpy for my target equation is positive 72.5 kilojoules.